Hello and welcome. I am Mehedi Hasan. I am pursuing my MSc degree in Computer Science and Engineering at the University of Dhaka. I am also a research associate at Data and Design Lab, where we are working on designing and developing methods and algorithms for public policy using machine learning and deep learning approaches. So today I will be presenting one of our work entitled as an experimental study on the speech emotion recognition for Bangla language, which has been conducted by myself, Mehedi Hasan, along with Sarker, Ahmed, Rumee, and Moinul Zaber. Our paper ID is 32. So when we talk about speech emotion recognition, what comes to our mind first? That what is actually speech emotion recognition? So let's have a look at the example first. So once one of my friends said that he has lost his credit card. Sad, eventually. So um, what I was thinking that before replying him, how is his emotional state or how is he feeling? I wanted to know that. So what I did is I observed his words, that what he said, how was his voice, how was his volume, and from that I came to a conclusion that okay, he seems angry instead of being sad, so I should say something that would lower his anger. So what actually I did here is I tried to understand his emotional state from the uh, words from the sentence he spoke. So this is actually what speech emotion recognition is, or and how it works. This actually addresses another question, that what is the importance of understanding emotion in speech or conversation or AI system or something like that. So let's have another example. So once I asked a chat, once I said to a chatbot that I'm feeling down today. So what I was expecting that it would come up with some suggestions for sharing up my mood, but as it was not able to understand my emotion, it replied something else, which was not suitable at that moment. So if the chatbot was able to understand my emotion, I could have better experience or better service from that AI system. So this is one of the major points, that how to like have better experience on AI system. So concentrating on that, this research work was initiated by few questions that came to our mind, that if someone wants to work on the Bangla ACR or Bangla speech emotion recognition task, what are the available data sets are over there, or and how are the characteristics of those data sets. So from our desk research, we have found that very few datasets, only a couple of datasets are available in Bangla language for this kind of work. From that, another and some few questions came up, that how good are the datasets? Are those sufficient for having a system that would be real life applicable or achieving state of the art results? And if not, that if not sufficient, then what are the options for us, that what we can do, and what are the scope of improvements? So this work actually concentrates on these questions. So what we have done here is we have evaluated Subescon Bangla ACR, which are the available datasets in Bangla for Bangla ACR. And this work has been conducted in 3 different approaches using 3 different dataset setups. And from this study, we have concluded that these datasets may not be sufficient for achieving benchmark results. And this study also points some future research directions for enhancing the performance of data resources for Bangla ACR task. Now let's look at the datasets we have been talking about. So datasets of Subesca and Bangla ACR, which are both in Bangla obviously, and those datasets are acted. That means those datasets are created in a controlled environment by few individuals who has recorded the some sentences multiple times, and the emotion data that this dataset contains are simulated by those individuals. So comparatively, Subesco is larger with 7,000 audio clips covering 7 emotional levels and summing up to 7 hours and 40 minutes approximately. And Bangladesh here is not that much rich in count, but yeah, it's good. With 1467 audio clips covering 5 emotional levels, and the duration is about 1 hour and 29 minutes approximately. So as you can see that Bangladesh doesn't have two emotional levels, that is disgust and fear. So when we merged these two datasets in a bigger portion, we can see that there's a slight imbalance in the dataset, so which we will discuss later. And now let's concentrate on the audio features. So from our study, we have seen that these audio features are suitable for representing emotional information in speech. So we have elected these features for this work. And as a model architecture, we have experimented with different models and different complexities. From those, we have selected three architectures for three best performing architectures for further research on three setups. So the architectures can be divided into two segments. One is feature learning segment, which consists of three convolution layers, and three and another one is classification segment, which consists of three neural network layers and one output layer. The major difference between architectures for different setups are in complexities that actually varies from setup to setup, starting the most complex for larger datasets and less complex for smaller datasets. As I've said before, that 6 units have been done using three different dataset setups and three different approaches. So if you look at the dataset setups, first we have evaluated Bangla, ICIEV and USK individually, which we have named as setup 2 and setup 3. Later we have merged these two datasets in a combined dataset, which we have named as setup 1. All these three setups have been evaluated and experimented using the same approaches and same pipeline. And if we see about the approaches, then we have experimented our initial exploring with the different deep learning architectures and different complexities, which have been done without any cross validation. From that, we have selected three best performing models, one for each setup, and moved forward to cross validation phase, where we have applied a five-fold cross validation on top of each best performing models. And due to some overfitting issues, we have applied regularization on top of the cross validation. And if we see at the results, then we can see that these models are very good at predicting very high arousal, such as anger, happy, surprise, or very low arousal, such as natural emotional levels. But these models have faced difficulties in recognizing a less arousal or mild arousal emotional levels, such as fear or disgust. So this can be a scope of improvement for future works. And one is concentrated on the precision and recall. And F1 score, we have seen a very interesting behavior. Though the combined data sets only have data for fear and disgust level from only the Subesco dataset, but when we have seen the performance, that the performance has increased for the combined datasets for these two levels. So we have concluded that other data of other levels from Bangla ICIEV has influenced for increasing the performance of these two levels, though Bangla ICIEV didn't have any direct contribution of data for these two levels, that is fear and disgust. Another behavior we have observed that when a dataset have performed low for specific level, then another dataset is not very much capable of overcoming the loss of the other dataset for that specific level that has been made by the previous dataset. And if we see at the cross validation results, we can see that before the cross validation, the accuracies was more than 70% in all setups, but when the cross validation was applied, the combined dataset and Subesco has faced some serious performance drop, while the Bangla ICIEV has performed very well, though it has faced some performance drop, but not that much compared to the only Subesco setup and combined setup. So we conclude that merging Subesco may drop the accuracy with cross validation for this work. And if we see in the result of cross validation with regularization, we have seen that again Bangla ICIEV has dominated the performance with a very good margin, and we have observed that as we have increased the value of regularization parameter, the performance of the model has decreased for Bangla ICIEV and others, and if we decrease the value of regularization parameter, the performance of the model have increased with a good portion. And now let's concentrate on the future directions. As we have observed that the data volume is a major concern that is not very rich. So if we increase the data volume, that may have a very good impact on the performance. And later is the transcription variation that we have observed that these two data sets have very less transcription variation. That means these two data sets are built on very few transcripts. So if we can increase the transcription variation, there may be a good impact on that. Another major concern is the emotional intensity for each emotional level, which is missing in this dataset. So we can focus on developing corpus for with emotional intensity for each emotional levels in future. Another concern is that these two datasets are acted or simulated, which is not very suitable for natural or real life applications. So we can focus on more on developing natural emotional corpus that will be more suitable for applying in real life applications. And with that, we can conclude that we have evaluated Bangla ICIEV and Subesco for Bangla speech emotion recognition tasks. And this work has been conducted using three different dataset setups on the different approaches. And we have found that these datasets are very good at representing high arousal emotional data, but not that much for low or mild arousal emotional data. And this also says that these datasets may not be sufficient enough for achieving state-of-the-art results. That is a basic requirement for improving towards a very good ACR dedicated in Bangla language. So that's all of my presentation. Thank you.